Okay, so today's day 3. We're going to do some factoring special cases and review. Reminder, there is a quiz next class. So starting out with our special cases, remember we have the steps from last class, and I will pull those notes so we can take a look at those. So last class we had these 6 steps that we can always revert back to, even if we have special cases. So for our first special case, we're just going to go ahead and factor as if we didn't realize it was a special case, and we'll use the steps from last class. So just factoring trinomials. So the one thing I need to do is I need to go ahead and do my x factor, build my x. So my a is this what numbers with the squared term, so 1. My b, there is no x term, so it's like 0 x's, so my b is 0, and my c is negative 49. At the top of my x is a times c, so 1 times negative 49 is negative 49. At the bottom of my x is b, 0. So I'm looking for 2 numbers that multiply to negative 49, add to 0. Well, because they multiply to a negative, that means one of them has to be negative. Because they add to a 0, that means when they battle each other through that addition, they cancel each other out, so they're the same number, just opposite signs. So negative 7 times 7 is negative 49. Negative 7 plus 7 is 0. Now I'm going to split my b term, so my middle term that is not listed, I'm splitting it. So x squared minus or plus 7x minus 7x, and drop down minus 49. It didn't matter how I wrote those down, I just chose to do it that way. I could have chosen the negative first. All right, so then comes so we did label ABC, we did the x, we split the b term, now factor by grouping. So the parenthesis party. First 2 together, last 2 together, plus in between them. So what's my GCF of x squared and 7x? I can divide out in x. X squared divided by x is x. 7x divided by x is 7. The x's cancel. What's my GCF of 7 and 49? Well, they can both be divided by 7. We just have to divide, see if it's positive or negative. Negative 7 divided by 7 is negative 1. Well, I want it to be positive, so I'm going to divide out a negative. Negative 7x divided by negative 7 is 1x. Negative 49 divided by negative 7 is positive 7. So my final answer is still going to be 2 binomials multiplied together. I'm going to take my GCFs, my matching pieces, factor those out, so x plus 7, and I'm left with x minus 7. Final answer. So notice I was able to take the negative 7, positive 7, and plop those in. Okay, and the x split into, or x squared split into x and x. These difference of squares will be something squared minus something squared. So they'll both be perfect squares. And it will end up being the first one plus the last one, the square of that number, and the first plus the last. So let's look at this one. If I were to square root 16a squared, I would get 4a. And if I was to square root 25, I would get 5. So my final answer for this is 4a plus 5 and 4a minus 5. This is the shortcut. If I square root each of these, then we have 1 plus and 1 minus. And I can always redistribute it back out and do the whole FOIL thing. Doop, 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 doop. And I would get back to my original answer. If you forget how to do that, absolutely throw the 0x in the middle and do the x method. So let's do the next one. If I square root this term, square root of 9 is 3, square root of y squared is y. Then I square root 100, so square root of 100 is 10, square root of z squared is z. So I have 3y plus 10 and 3y minus 10z. You try the last one. Oh, this one's actually a little bit different. So when I see 24, I know that 24 is not a perfect square. 25 is. So this one has a new first step. If we take out a GCF, take out GCF first, I bet we can get this down to perfect squares. So let's think of our GCF of 24 and 54. If you are drawing a blank right now, grab your calculator or your iPad, go to that graphing calculator app. I'm going to press the math button, click over to num, and then I'm going to go to GCD, typing in 24, 54, enter. So I can factor out a 6. If I divide out a 6, 24 divided by 6 is 4, x squared. Negative 54 divided by 6 is negative 9. So it is a difference of squares, which is perfect because it has to be a difference for this to work. When I square root this one, I would get 2x. When I square root this one, I get 3. So this is going to become, 6 is just going to sit out front, and I'll have 2x plus 3 and 2x minus 3. These next ones are perfect square trinomials. So what does this look like? My final answer would end up looking like a plus b quantity squared. So let's go ahead and just show you what that looks like. So a plus b times a plus b. It's saying write that twice. So if I distributed a times a squared. A times b is ab. They're not like terms, so we just set them next to each other. B times a, b again. I just put them in alphabetical order. B times b is b squared. If I combine these terms in the middle, I would have a squared plus 2ab plus b squared. This is the format that they sit in. Okay, and this one would be a squared minus 2ab plus b squared. So the first and last would be perfect squares. The middle one would be 2 times the square root of those two terms. My best advice to you is to, if you recognize this pattern, you can use the rule. But I would probably stick with using the x for these ones. And just we can manipulate our final answer. So let's build the x. A equals, b equals, c equals. So a is the term in front of the squared, 1. B is the term in front of the regular variable, so 12. C is your constant, 36. At the top of your x, 1 times 36 is 36. At the bottom of your x, b, 12. Two numbers that multiply to 36, add the 12, 6 and 6. You should get the same number for these ones. Okay, so I'm going to go ahead and I know I could use my shortcut because my first term is 1, so I could make it x plus 6 and y plus 6 and y plus 6. I'll go ahead and show you splitting this up just for practice sake. So y squared plus 6y plus 6y plus 36. First two together, last two together, plus sign between them. I can divide out a y, and I'm left with y plus 6. Here, I can divide out a 6, and I'm left with y plus 6. Because 6y divided by 6 is y, 36 divided by 6 is 6. All right, if I factor out my GCF here, y plus 6, then I'm left with y plus 6. This is absolutely an acceptable answer. However, because both of these are the exact same thing, or we could write it like y plus 6 quantity squared. Either is acceptable. Let's do the next one. This one I'll show you that shortcut. So I'm going to label these A, B, C. A is 1, B is negative 16, C is 64. So creating my X at the top, A times C. So 1 times 64 is 64. At the bottom, B is negative 16. Two numbers that multiply to a positive. They're either both positive or they're both negative. Because we add to a negative, that means they're both negative. So I got negative 8 and negative 8. I could absolutely split my middle term and do the same steps that we did over here. Or, because my first term is 1, I can make this, we're using x's, so x minus 8 and x minus 8. And we can rewrite this as x minus 8 squared. Okay, either one is acceptable. So on this backside, we're going to review factoring. All of these problems that we've seen so far have told you to factor. So part of your job is realizing which factoring method should I use. So we have learned 3 of the 4 of these so far. So GCF, when are we going to use GCF? We're going to use this when we have usually like 2 terms, or when we can only divide out a number and maybe a letter. Grouping, we use this when we have 4 terms. So remember, this is the parenthesis party. X method or special cases. So this is when we have trinomials, or if we have difference of perfect squares, or if we have those perfect square trinomials, we can use that. Quadratic formula, we will learn soon. Okay, so we don't know this one yet. All right, so we always want to make sure it's written in standard form. So we got the square term, then the regular x term, then the constant. We want to look and see if we can take out a GCF. Maybe we can divide out a 2 right away and give us some smaller numbers. And then choose which method to factor. So let's look at example 3a. So we only have 2 terms here. So I know I'm not doing the factor by grouping because I would need 4. I'm not using the x method because I would need a squared value. So I'm just bouncing back to the GCF. So what is the biggest number I can divide 12 and 24 by? Well, I can divide them both by 24. Now we have an x and a y. They're not the same letters, so I cannot take out any letters. 12x divided by 12 is 1x. I could put a 1 here if I wanted to. I don't have to. 24y divided by 12. 24 divided by 12 is 2. And then y divided by no y stays y. B. A squared minus 4ac plus ab minus 4bc. So there's a lot going on there, but I am noticing that I have 4 terms. 2, 3, 4. Okay, I can't take out any GCF right now because, let's see, these don't have numbers, and this has an A but no B or C. So they don't all have A's, so I cannot take out any A's. So I'm going to go ahead and do the factor by grouping. 4 terms, so first 2 together, last 2 together, plus sign between them. A squared and minus 4ac. So both of these have at least one A. I can divide out A. A squared divided by A is A. Negative 4 divided by 1 is negative 4. A divided by A, cancel. C divided by no C is C. All right. AB minus 4BC. What letter do they share? A's? No. B's. Yeah, they each have a B. So I'm going to take out a positive B. AB divided by B. The B's cancel, and you're just left with A. Negative 4BC divided by B is negative 4C. These match, so that tells you you're good to move on. If they didn't, you'd want to be sure to go back and check your work. Factoring out that matching piece, so I have A minus 4C, and I'm left with A plus B. Again, it does not matter what order you write that in. I could have written it as A plus B times A minus 4C. That would have been fine as well. C. So right away, I'm not noticing that this is anything super special. So I'm going to go ahead and use my X method. So I like to label. A is 1, B is 14, C is negative 32. So at the top of my X, A times C, so negative 32 times 1 is negative 32. At the bottom, B is 14. Two numbers that multiply to negative 32. That means one of them has to be negative. Because they add to a positive, that tells me when they battle each other, the positive is the bigger number. So 32 divided by 2 is 16. I'm just kind of cutting it in half to see if I can get the numbers close. Negative 2 and 16. Those multiply negative 32, and they add to 14. So that's right. I'm going to split my b term with those. So y squared minus 2y plus 16y minus 32. Now comes the grouping step. So I'm looking back at my day 2 notes following these steps. First two together, last two together, plus in between them. Y squared divided by negative 2y is y. Y squared minus 2y. I'm factoring out a y. So y squared divided by y is y. Negative 2y divided by y is negative 2. GCF of 16 and 32, if you're drawing a blank, you could think, well, these should match. So how do I get a 16y into a 1y? Well, what is 16 divided by 1? Positive 16. And now double check, negative 32 divided by 16 is negative 2. They match. My final answer is two binomials multiplied together. One of them is my GCF matching piece, so y minus 2. The other is y plus 16. D. 2a squared plus 13a minus 24. So I'm not seeing any perfect squares here, so I'm going to go ahead and factor like normal. So a times c, so a is 2, b is 13, c is negative 24. At the top of my x, a times c, so 2 times negative 24, negative 48. At the bottom is b, 13. Take a second and see if you can find your factors here of multiply to negative 48, add to 13. Okay, so if you plug that in your calculator into the y equals, I'm going to type in negative 48 divided by x, second graph. I want them to add to a positive number. So right now, 3 and negative 16, that adds to a negative 13. So if I go the other direction, negative 3, and positive 16, that adds to positive 13. Those are the numbers that I want. Split my b term. So I have 2a squared minus 3a plus 16a minus 24. First two together, last two together, plus sign between them. 2a squared minus 3a. Well, I cannot divide by any whole number because it's 2 and 3. Largest number that those are divisible by is 1, but I can divide out an a. 2a squared divided by a is 2a. Negative 3a divided by a is negative 3. GCF of 16 and 24 is 8. If I draw a blank, I'm thinking, well, how do I get from a 16 to a 2a? What is 16 divided by 2? Positive 8. Now negative 24 divided by 8 is negative 3. These match. We're good to move on. Final answer, a plus 8, and one of my matches, 2a minus 3. We're going to have two more because I'm going to add one for you. Just reviewing the new stuff. So 3x squared minus 6x minus 45. Cannot use the shortcut because my first term is not 1. So let's go ahead and label a equals 3. B equals negative 6, C equals negative 45. Ooh, I am noticing right now though, 3, 6, and 45, those are all divisible by 3. So I could keep working this problem out as is, or I could attempt to work this out with smaller numbers. If I did that, if I divided it out of 3 right now, then I would be able to use my shortcut. So 3x squared divided by 3 is x squared. Negative 6x divided by 3 is negative 2x. And negative 45 divided by 3 is negative 15. Now my a is 1, my b is negative 2, my c is negative 15. I can use my shortcut, and I will show you that. So if I didn't realize that I could take out a 3, I can just go ahead and continue with these numbers up here, do the x, do all of the same steps like we did here, and work it out. Or I could take out a 3, dividing each term by 3, thus making these numbers smaller. This 3 doesn't just go away though. It would come down in front of my final answer. So still have two binomials, but the 3 would just sit out in front of my final answer. Now let's build our x using these new numbers. So a times c, 1 times negative 15 is negative 15. At the bottom, b, negative 2. Two numbers that multiply to negative 15 means one of them is negative. They add to a negative 2, that means the bigger one's negative. So negative 5 and positive 3. So because my first term is now 1, I can say, okay, this is x, and it's negative 5, so x minus 5, positive 3, so x plus 3. If we worked it out with these numbers up here, we'd probably get like 3x plus 15 and x plus 3. Or 3x plus 9 and x minus 5. And it would still work out the same way. Your final answer still is the same. It just depends. You might distribute this. So, okay, let's take a look. I'm going to add one example. We'll add example F. And this is again just reviewing from earlier. 49x squared minus 64. So I could try to see if I could take out a GCF, or I could realize, well, 49, that's 7 times 7, so it's a perfect square. And I have a difference of 8 times 8, so that's another perfect square. So if I was to square root this term, square root of 49x squared, I would get 7x. And if I was to square root 64, I would get 8. So I would have 7x plus 8 and 7x minus 8. That is one of those new methods that we learned today. If we didn't realize it was a perfect square, then we could add in 0x in the middle and do the x method.